Hey guys, welcome to a new week of physical science, and today we're going to talk about longitudinal waves. So, longitudinal waves, we've already talked a bit about them, but we're just going to go into a little bit more detail about their characteristics and what they do. It turns out they have a wavelength, an amplitude, and a cycle, just like transverse waves do. Two terms that are different though, instead of calling the top of a longitudinal wave a crest, we're going to call it a compression. Instead of calling the bottom of a longitudinal wave a trough, we're going to call it a rareflection. Not a reflection, a rareflection. So, as a review here, on the top picture, you'll see a transverse wave. And on the bottom picture here, you'll see a longitudinal wave. The difference here with a transverse wave, as it propagates, that's the term, as it moves from left to right, at some point in time, the wave is high, and at other points in time, the wave is low. With a longitudinal wave, the difference here is that as it propagates from left to right, the particles are also moving from left to right instead of moving up and down. So at some times it's compressed, and other times we see that rareflection there. So you'll see in some areas, the dotted line areas, that's where the wave is a bit more compressed. And then in those more open areas, that's where it looks to be more expanded. So picture this bottom picture here kind of like as a spring. Sometimes it's compressed, sometimes it's opened. What I want to show you here is there's the crest and the trough, and I want you to look at this blue line. So you'll notice that as we start the blue line, it's going to, at the middle of the trough here, that's where it's the most expanded, and then at the top of the wave here, at the crest, that's where it's the most compressed. As it reaches another trough, very expanded, and as it starts to reach that crest, it becomes more compressed. So, it turns out that these two waves are actually very similar in that they both complete, let's see, 2 cycles. So, let's look at this again, but now I'm going to label the longitudinal waves. I'm going to label one compression and label one rarefraction, one part where it's expanding a little bit here. And again, watch that blue line as it moves over the two waves. Notice how as it nears the trough, it's expanded, and as it nears that crest, it's compressed. As it nears the other trough, once again, it expands into this rarefraction, and as it meets that final crest, it compresses. So, to label this longitudinal wave, we can label the other crests and troughs on the transverse waves, and we can label the other compressions and rarefractions on the longitudinal wave. So that's kind of every part of this labeled. Now, we're going to use these same two pictures of a longitudinal wave and transverse waves to talk now about wavelengths. Oh, sorry, here's one last time, just kind of seeing this, how it looks. It's beautiful. Great. Okay, so let's talk now about finding wavelengths. When it comes to finding wavelengths in a transverse wave, you can look at it from crest to crest. That's one way to determine a wavelength, trough to trough, or from a 0 point to a 0 point. So here, the top one here is a crest to crest. The bottom one here is a trough to trough. And in the middle here, we see from a 0 point to a 0 point. Each one of these is the same distance, so they're all one wavelength because it's the same wave, so it has the same wavelength at those 3 different points. But it's just kind of showing you that depending on what you prefer, there's different parts of the wave that you can measure to figure out what the wavelength is. The same thing is true then for a longitudinal wave. You could look from crest to crest, or from the middle of each compression, or the middle of each rarefraction, or if you can find it, you can kind of see where it goes, where it's halfway between a rarefraction and a compression, and you can measure that one wavelength. If we didn't have this transverse wave right above it that was identical, it might be tough here to see kind of where the wavelength starts and where the wavelength ends. That's why I like this compression to compression method. Find the center of the first compression and find the center of the second compression, and when you do that, that's one wavelength. It's hard to find wavelengths for longitudinal waves, so you just kind of have to be close, and there is a little bit of estimation that goes here. It's not as easy to identify as it is with a transverse wave. For amplitudes, if we look at the transverse wave, remember amplitude is just the top of a peak from the 0 point. Amplitude for a longitudinal wave is this whole thing. This whole thing is an amplitude. So it looks like the amplitude of this longitudinal wave is twice as big as this amplitude of the transverse wave. Fun fact. Last thing I wanted to show you is cycles. Here, once, as I said earlier, both waves go through 2 cycles. So you can kind of see half of one compression to half of the other compression. That's what a longitudinal wave looks like. That's where its cycle is. I guess that's one way of measuring it, right? You could measure it from kind of crest to crest or middle of compression to middle of compression. If you wanted to, you could also measure it from middle of rarefraction to middle of rarefraction, or from kind of in between where the rarefraction starts and the compression starts to in between where the rarefraction starts and the compression starts. So I'm going to show you what those 3 would look like with their corresponding transverse waves here on the next slide. So here we'll see crest to crest, that's what I just showed you, and you'll see how the middle of each compression, that's what it looks like. Those are what the cycles look like. Here it goes from trough to trough. So here I've tried to kind of find the middle of the rarefraction for each one of these. And then the last one is going from 0 point to 0 point on that transverse wave. So I've tried to kind of find, I don't think I did a great job with this last one. It was kind of hard to make that last one, but yeah, that's just showing you what a cycle is. You don't have to be able to determine all of these. You would just have to, if we gave you a longitudinal wave, figure out where's the middle of the compression, where's the end of the other compression, and figure out a cycle from there. Great, so that's a little bit on longitudinal waves. I hope you guys learned something, and I hope you guys have a great rest of your day. Take care.